Um, oh, and then just like kind of your question, Logan, from the back in the day. It seems like I haven't gone in the book for a while. Well, we finally got back to the book here. All right, so it is a book assignment, and they're odds. So like oh, okay, sorry, number two, I just see showed up there, but they're all odds, so you can at least check the answer in the back of the book or answers if there's more. So hopefully you know where that's located. I forget what section that's called. I think it might be A for answers. I don't know. It might be a section A for answers, but you can flip in that book and see that happening. All right. And then, ooh, there's a naughty word on May 4th. By the way, May the 4th be with you. Wearing my Star Wars shirt tomorrow. I got one of 30 to choose from. Not sure which one I'll use, but yeah. All right. So hopefully you remember this. Why is that thing up there? Get that out of there. Move my fat head up here. All right. Law of sines, law of cosines. See, this is what this exists for, and this is why this is in this book. It's still trigonometry. And in this case, though, are we done shuffling some papers in there? Let's go. We got the notes going. All right. This is dealing with triangles that are not right. So you cannot do SOHCAHTOA. By the way, what sine of a 30? You know what the new answer is? Who cares? You can say that now because guess what? We're done. We're done. We're done with that. We're done with the unit circle. We're done with sine of a 30 is a half, cosine of a 60 is a half, and all that other stuff. It's over. You don't have to hear me moaning about that, you not knowing that. All right. It's going to be all pretty much calculator work and all basic trigonometry and just those basic relationships. We could almost have done this chapter like right away in the beginning of this semester. It's really what it is. Now, I'm going to put this down. This is globally for the whole chapter. When one side and two angles are known. Remember this back in the day? Ooh, sorry for my scratchy work there, but AAS or remember, ASA was one of those ways that you could prove two triangles are congruent. You remember that back in the day in chapter one? I'm sorry, chapter one. What am I talking about? I meant your freshman year. I have no idea where chapter one came out of my brain for that. But this is depending on what's given. And when those are given, we will be able to, and we're going to break this down why the law of sines is great for this. So when you're given AAS, two angles and a side in any case, law of sines is going to be very solvable. And there's a very simple reason why, and I'll show you that. Two sides and one angle not included. All right, so that is, here comes the naughty word. Oh, let's put it over here. ASS. Oh no. And I'm going to purposely put that naughty word. This naughty word for the law of sines creates a big problem. And we're going to separate that tomorrow. All right. That's tomorrow's issue. It's called the ambiguous case. You should put a big star by this, that this is going to be one of the only problems of this chapter. This is going to be one of those things where I got to step up a little bit and figure out something special about this. But this is still law of sines. And we're going to, at the end of these notes, show you why the law of sines doesn't work for 3 and 4. All right. 3 and 4 are two sides in an included angle. That's SAS. So two sides of a triangle and the angle in between those two sides. When that's given, the law of sines will not work. Therefore, you're going to need the law of cosines. And again, after Thursday's notes, I think Thursday we'll get to the law of cosines, I believe. Maybe I'm off. Maybe that's not till Friday, depending on how we spread this out. You'll see why the law of cosines need to be used. And then for SSS, when three sides are given, that is also a law of cosine scenario. So that is not going to be until 7.3. That's the last part of our note sheet that you have here if you flip through the pages. But we got some stuff we got to break down with that as well. So that's the overall up to 7.3. And we are going to have a quiz going back to the calendar a week from tomorrow. So hitting the calendar real quick. That's a nice little separation between what we're going to do after that for the last week and a half, which is vectors, which needs the law of sines and cosines. So we're going to do vectors after that. Kind of a neat introduction of what a vector is. Vector is a really real world application to how things work out there. Traveling planes use vectors in their instruments in order to get to or know where they're going to end up at, depending on their flight path and how fast they're going, blah, 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 blah. Vector is a big physics concept. Anyone in physics or have been? Raise your hand. Vectors, right? Heard of vectors before? So some things will be crossover, but we're not going to get into the physics part of it. Okay, and then here we go. This is why this isn't rocket science. Law of signs is so easy to remember. As a matter of fact, don't even ask, is there going to be a formula sheet for this? It's ridiculous. I mean, look at this. Lowercase, by the way, is what? Sides or angles. What do you think lowercase represents? Sides or angles? Sides. So it's side A over sine of angle A equals side B over sine of B, and so on and so on and so forth. I don't know why. I always like using this version. Doesn't really matter, though. All it is the flip version of the one above. But I will most likely always write that one down. I don't know why it's just stuck in my head. And you're only going to use two of the three. And I probably should put this up in this box. Remember, when drawing triangles, letters match for corresponding angles and sides. So maybe off to the right here, you should put triangle ABC. And I don't care where you put A, B, or C. You want to put A at the top, C on the, left, it doesn't matter. What does matter, though, now that this is side A, side lowercase a is opposite angle A. All right. And that's one of the first things you're going to need to do when you're given questions. If it's not given in a drawing, you should really draw it. You should really get this relationship down. All right. That this is the case. And then it becomes real easy. And it really, really is. By the way, get your calculators out. Hey, when I'm a jerk and I delete your memory on your calculator, go ahead and do that real quick. Do a second plus. Just do it. Just so when you exercise and you do the actions, you understand that this occurs. So do second plus 712. So second plus, and I guess I can emulate this as some people are still getting to their bags. Remember how long it takes for this calculator to open. I really want you to help me on the calculations, though, so I don't have to pedantically go through the calculator here. Ooh, big word, pedantically. I mean slow. Okay, second plus, 7, 1, 2. All right, the reason I had you do that is this is a default. When you reset your calculator, go to mode right up here. Boom shakalaka. What am I in right now for trig? What's the problem? We're in radians. We're not dealing with radians in this chapter. This chapter is all real world measures, all in degrees. So if you're not in degrees, you will get every single question wrong. I don't know why I can't hit enter. There we go. Now it's blackened. So that means it's in degrees now, shifted over there. So my what I didn't finish saying, when I'm a big jerk and I delete your memories because there's cheaters out there, it goes to radians. The very first thing you have to do is put your calculator in degrees before you continue in this chapter. All right. I'll try to remember to tell you that when we do that, but just thought we'd go through that real fast. All right. So this first silly example, no drawing given. In your homework, they have the drawings probably in some of the questions, and then all you have to do is just set up the trig. And I don't know if they necessarily say solve the triangle. It might just ask you to find one part. Yay. Thanks, Ben. There we go. So solving the triangle actually means finding all the missing parts. So what you should do first is draw this triangle. I couldn't care less what the triangle looks like. My triangle will always look like a pumpkin eye. I mean, I just do that because all I care about is who goes where. I don't have to show 32 degrees and make sure it looks like it's a 32-degree angle using a protractor. No way. But if I know A is here, then I must know side A is over here, if that's where I decide to put it. And they do have side A. Thank you, pen. See how many times we could ask the pen to stop doing that. And then I'm just going to decide to put B. Don't erase if you put B at the top. It doesn't matter. It doesn't matter. And that's what I mean about I don't care how this looks. 81 is a bigger opening than 32. I don't care. And nor should you. You just need to know where B is. So, it's almost close to 90 degrees. I'm not going to try to make it look like it's close to 90 degrees. Oh, and then the last thing is C is up here and little c is down here. So in solving the triangle, I must find these three missing parts. And that's the idea of solving. First of all, who's the easiest one to solve? And I would not want to see work for this. The angle. Is that what you said? The angle? Angle. Okay, gotcha. All right, so angle. C. What's the sum of three angles in a triangle? 180. So it's 180 minus 81.8. Could someone please type this so I don't have to go to my calculator? 67. That can't be correct. It's got to be 0.2. 60 what? 66.2. Do we got a yes on that? Yes. If we get this wrong, then I use this to find other stuff. That's going to be wrong. I don't have to have this written. I'm doing this for no purposes. But just note that angle C is 66.2 degrees. Simple Simon stuff. You guys, that might be 1 point, though, in these days. Like, fine, I'll give them 1 point for at least finding that missing angle by doing 180 minus. It's going to be a 4-point question, though. All right, now the next thing. So I might want to put that in. It didn't have to be my first thing. But now the next thing is, this is why the law of sines works. Remember what it said, you're only going to use two of these three. You've never seen an equation with three sides. Just making the point that I could use any two of those three in that equation to be true. All right, so hopefully you understand that and not making that too complicated. Oh, I guess I'll change color just for a different step. The next one, I can find any of these remaining sides, but I'm going to find the one that I could have found right away, which was B, because I had angle B. So it's sine of angle B. It's always so goofy. Those that don't like do their homework or whatever, they just set up a ratio, 81.8 over B. No, it's the sine of 81.8. You sine an angle measure divided by B equals, and then notice what's given. Sine of 32 over A, which is 42.9 centimeters. I don't need to write centimeters. This is why the law of sines works for when I'm given two angles and one side. How many unknowns are in that equation? It's very simple. One, very solvable. When you're given SSS, if you could just think for a second, if I was given side, 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 how many unknowns would I have? You don't know any of the whats. They start with an A and ends with angles. I don't have the time for this. Angles. So how many unknowns would you have if you were given SSS? Two. You'd have these two sides. Remember, you're only using two of the three equation or parts of this equation, but you'd be missing two angles. That is unsolvable. All right. One unknown is solvable, not two unknowns. So that's what I really want to get to, why it's law of sines for certain things and law of cosines for others. Anyway, my sophomores had problems with this, and this is really basic skills of solving. But when I have a fraction that equals fraction, this is cross multiply. So I will cover this real fast, but I would hope in our high-level math class, we wouldn't have to show all of these steps in order to solve for this. And you do put the 42.9 in front of the sign. It's a better thing to do when you're typing on the calculator. So cross multiply, I really shouldn't have to show this cross multiply step. And then divide by sine 32. And really, this is all that you type on your calculator. And I guess since I have it open, I will go ahead and do this. Did I change mine to degrees? I think I did. So you have to divide both sides by sine 32, and then this is what you press. So now I'm going to go to the calculator. Good that I left it open. Let me shrink this down so I can see what I have to type. 42.9. I would do this. 42.9 times, I guess. I didn't really have to write times. Sine 81.8. This is not lazy. This is actually better for you to do. Just press enter. And then take that answer divided by the sine of 32. And then hit enter again. Because if you don't close those parentheses and then hit divide, you're going to get it wrong. It's not correct. So I just like getting the numerator done and then divide by that when you're done with that. So 80.12. Let's go 80.1. Usually on sides and these angles, you do one decimal place. Thanks, Ben. Oh, I can't believe I know that works now. Slamming it up against the computer. It's great. And then let's see how much room do I have here? I guess I could do this down here just for the purposes of changing colors. Now I'm going to do what in the world was that? Oh my goodness. It's such a fun year with this pen. C. Okay. So I did the 180 minus and now I have C. Sine of 66.2. Isn't this easy? Divided by C equals the given sine of 32 over 42.9. And I got to get that hidden. Okay. And then through cross multiplying, you should know that C ends up equaling 42.9 times sine of 66.2 divided by sine of 32. Wish I could pause and do the calculations offline, but I don't have that option with this thing. So again, 42.9, slow. Can't tell me I'm going too fast. Sine 66.2. I did check that I was in degrees, not radians, divided by sine 32. You'll be much faster than I. All right, then 74.1 is the nice rounding for that. 74.1. Something to check on this. First of all, you'll get some goofy answers if you're in radians. Like you might get a negative side measure. That can't happen in real world trig. You're probably in radians. But also double check this, that the opposite side of the largest angle is in fact the largest side, 80.1. You see that? And the smallest angle still has the smallest side opposite it because letter C is 74.1, which is in between those other two sides. So sometimes when you mistype something, those basic relationships are don't hold, I guess we could say. So I guess for purposes of doing this one, it's just two angles and a side again. I don't think I really need to do that one. It really is, maybe I'll go to the end and just show you how easy that one is if you wanted to pay attention or not. Because really what you need me for is this one. Do you have this on your sheet? Yes or no? I did get it in there because some of the things I didn't. I printed that sheet and then I had inserted some other stuff. Oh no, this is where this is not a math 2 question anymore. This is our cat question. This is where I was going to go up to the board and actually put these, maybe at the end of class, I'll put them and hold them there for the week and hit save. Bearings. Okay. I'm doing these bearing questions that I said was going to come back. And you're really going to need to know your geometry for this in order to get this done real quick. So I don't know if you have some extra space off to the side, not where this question is. Maybe on the back of that, flip over, go back to the front page, and then go to the back. You have a completely blank page on the back of your sheet. Just a reminder of what bearings are, okay? So let's just break this down real quick, and then we'll insert it in the question. What does it mean to be north 42 east? Well, first of all, that means you're traveling somewhere or you're looking somewhere. So here's the point that you started from and traveled, or you're looking to something that's north 42 east. And at this point that you're looking at, so put this at the top of your thing, north 42 east. What does that look like? Right, just to remind you. Well, you put a crosshair on this, and this crosshair is a compass. And I don't know why I missed that dot. North, south, east. I almost put east over there, and west. Isn't that right? Isn't west left on the? I'm freaking out for a second. Now, you're not going to put north, south, east, west on every single one of these, but maybe for this first one you should. Okay. And now what it means to be north 42 east, all it means is you go to the north axis and go 42 degrees in an easterly direction. So this angle right here is 42. And then you're either traveling in that position or you're looking to something over here. So this is where the object is, or this is where you ended up. And that's what I think was missing about this. This isn't hard, all right? It's very easy to draw these, right? But you just got to make sure you draw correctly and make the connections correctly with the overall question. And then north 15 east. I mean, that's easy. That's going in the same direction, but less of an angle measure. So north 15 would be off of there. But let's, for your note purposes there, Let's do like south 51 west. All that means is you have a starting position, which is the middle of the crosshair, and you go in a westerly direction off of the south axis. So this angle is 51, and then this is either where you traveled or what you're looking at an object that's over in that position over there. And that's all that it means. So whenever you're given north or south bearings, they're actually quite direct, and they're actually quite simple to draw. Okay, so keep that in your bearings. That's one way of doing bearings, and now I'll actually look at this question. Okay, see some people finishing off that south 51 west. What's going on? Is everything okay, Tom? Good. All right. So, two Rangers stations are at an east-west line, 110 miles apart. Stop! What should we draw right away? A vertical line or a horizontal line to connect these two stations? Horizontal. Come on, folks. I mean, the first thing is everyone should have the exact same drawing. Maybe with, a little different spacing and all that stuff, but where everything is in location to each other on the paper should look exactly the same. So always gets goofy. I got people drawing vertical lines when it's a direct east-west line. So here's our two stations. That's number one. Does it call these stations located at bearing A? Okay, from the western station A. What does that mean A is? Is it on the left or the right? Left. So they actually give you that information. That's nice. So if you just read that station A and that station B, because they tell me. Now I might be in trouble how large I made this. I might run into the word problem. So I'll make an adjustment. But a forest fire is located on a bearing of north 42 east from Western Station A. That's what I mean. This station has the crosshair on it, and it cites something in a north 42 east bearing. I am going to run into the question. And this is what you want to do. You want to draw this as far as you can. All right. So I did kind of crush the question. You probably ended up doing the same thing. So I might have made this a little too big, this east west line. And then a bearing of north. This is why I knew I had to do what I had to do. North 15 east from station B. When I draw this crosshair, north 15 east is still in this direction, but it's small. And that's why I had to draw this, because where the fire is the crosshair of these two sites. And unfortunately, this was north 15 east as well. I wish it was north like 15 west, then it would go in this direction, and then it'd be a smaller triangle, I guess is what to say about this. But here's what you got to do. You got to draw these angle measures. You got to put those angle measures where they are in reference to this bearing question. Otherwise, you will not get this taken care of very well. Now you're going to get mad at me because you don't have this option. If you've crushed your word problem, you don't get to do what I get to do, which is shrink this down. Well, maybe I don't. There we go. Cheater, Mr. Samuelus. Okay. Now, here's what's different with these questions compared to when this was in chapter 2, and this was in chapter 2 that we did bearings. That angle is not a what kind of angle. Why can't I use SOHCAHTOA? That is not what kind of angle. It's not a right angle. You don't get right angles on this. You really need to know your geometry on this in order to get these other angle measures. Fortunately, this one's easy. What is this total angle measure from here to here? Not 90. Knowing that this is a crosshair and that I draw it, this is 90 and that's 15. So what's the total? So it's 105. Knowing that you have a crosshair there, you know that this is 105, 90 plus. Luckily, we have that east-west line. That makes that an easier question. And then what's this? This always happens. You guys got to stop doing this. Is this angle measure 42 right here? Yes or no? I get that all the time. People just stick 42 right in that corner. What is that angle measure? That's actually 48 because this is a total of 90. This is basic grade school geometry at this point. All right. And that's what you have to really reduce this down to, how I get these angle measures. And then, of course, I can get that last one. I don't know what this thing is here. I forgot what. Oh, I pulled that from the word problem, right? It's just 180 minus. And I forgot to mark one more thing here. So 180 minus 105, 148, 153, 63, 73, 27. Right? Does anyone else agree with that? 27 degrees? Did the math kind of in my head there. Right? Oh, I forgot to mark one thing. I forgot to mark the one distance that they give you. Oh, they know that they're 110 miles apart, so that's 110 right there. How far is the fire from the western station, which is station A? Well, station A and the fire are this distance from here to here. So that's what I'm finding. I'm finding that distance, which is opposite 105. So to find that, now it's easy. It's sine 105 over x. We'll call that x, the distance that we're looking for. And that equals the only thing that's given that I can use, which is sine 27, because that is opposite the 110 that's given. Right? So after this, it's easy. Once you get the drawing, it's over. It's a really Mickey Mouse question to answer. Okay, and then hopefully you know from cross multiplying, fine, I'll do it one more time. X times sine 27. That's the basics of solving a fraction equals a fraction. 110 sine 105. Really keep in line what things are opposite what here. And then that's ultimately what I'm going to type on my calculator. We already typed on the calculator. You go for it. Someone tell me what the answer is. I'm waiting as people are writing this down. Anyone finish it? What'd you get? 234.04. So I guess if we went to the nearest whatever, that would be was this miles? Yeah, miles. 0.0 miles. Anyone else agree with that? Anyone else type it? Okay, I got a couple head shakes. Good. Glad you're in tune with this. I really hope you understand how easy this actually can be. I guess I should go back to the bearings thing because I don't think my next one has this bearings way. Or it has this way again, I think. But I might, after this next example, do show you on the back of your page another bearing type of question. Okay, so this one's cut off to the side of the book. That's why it's all red and all shoved like this, but it's okay. Bearing of a lighthouse from a bearing of a lighthouse from a ship was found to be north 52 west. After the ship sailed 5.8 kilometers due south, what kind of line do I need? A vertical or a horizontal? Now you need a vertical. The bearing was north 23W. Let's go back up to this. I remember when I first saw this question about 12 years ago, like, whoa, this one's kind of weird. Bearing of a lighthouse from a ship. So from the ship to the lighthouse, that's the bearing. So who gets the crosshair? The ship. And that's who gets the crosshair and how you draw your bearing on this. Now, where is the lighthouse compared to the ship? Is it above it or below it on the map? Above, and is it left or right? Above, and is it left or right? Left. That's how you want to understand how this shakes out, because the ship is starting here and the bearing from the ship to the lighthouse is 52 degrees north, 52 west. That is why the lighthouse is here. It says lighthouse. I was just double checking. So the wording, the bearing from a ship to the lighthouse, that means the bearing is to the lighthouse, off of the ship. So the crosshair goes on the ship. Really trying to help you on this wording and this verbiage here. And then I'll color it in green. The ship goes due south for 5.8 kilometers. Then it should make sense. What should this bearing do? Should it open or close the angle measure? It should close. It should get smaller, and it does. Right? Now it's north 23 east. Now remember how you do it. This goes 23 degrees here. North 23 still west. And that's why the lighthouse didn't move. The ship did. All right? So that's why that is the shape of it. Okay, a couple things on these angles. Find the distance between the ship and the lighthouse at each location. So we're going to find X and Y, which won't take that much. We just got to get all our angle measures. First of all, this angle measure is an angle in the triangle, 23. So that's lucky. How do you find this angle measure from here to here? It's the simplest thing in the world. 180 minus 52, because that's a crosshair from north to south, which should be 180. 52 of it's taken care of already. So this is 128, I believe, right? So this is 128, all of it. I'm going to go right through that crosshair and say that's 128 degrees. And then all you have to do is do 180 minus for the third angle measure, which I believe that's 51, 61, 71, 29. Correct? And then I want to get on to moving on to the area formulas. So how do I find y? Well, first of all, the given is 29. Sine of 29 over 5.8. That's our given, and I'm going to use that to find y, which is opposite 128. And then you can go ahead and type on your calculator. And then the other equation is given sine of 29 over 5.8. That equals sine of 23 over x. All right? Right, that's the beginning position. Sine of 28 over y, and then sine of 23 over x equals sine of 29 over 5.8. Right, and that's how you get your both x and y, cross multiply, and then you'll end up getting those answers. Okay? All right. Anyone get those answers, or do I just move on? No? Anyone type it? What's that? 9.4. Anyone get x? What? 4.7? It's weird because you're sailing away. Something seems wrong. Did I? And then what? Y was 9.4. Oh yeah, okay. What? Y should be longer. Sorry, I was looking at finding. I thought X was Y and Y was X. That makes perfect sense then. Okay. All right. And then I kind of talked about it. Why doesn't SSS work? We already talked about that. If I have a triangle that is 3, 4, 6, let's say those are the side measures. I don't know an angle. Let's say A is opposite 3. So sine of A over 3 equals, and I don't know this angle. This is unsolvable. When we get done with this little these 3 sections, there's no reason you should be choosing the law of sines when it's side, side, side. That leads to a situation that's not solvable. And then if you're given SAS, you might have to see this one. This is what SAS would be. Just for a lack of imagination, let's say this side is 3, this side is length 4, and then let's put in between this like 35 degrees. That's SAS, side angle, side. If I call this angle A, and this B and this C, then sure, I could do sine of A, which is 35. Problem is, I don't know A, the opposite side of that. So I already have one unknown. And then look, do I know any of the other 2 angles? No, I do not. So yet again, I have 2 unknowns. It'd be redonkulous to choose law of sines in this scenario. 2 unknowns again. That is why we need something different. We need a law of cosines. Right, so it's a good little question to put there at the end. Why would I not use law of sines in some other cases? What time did we get out of here? 15? I actually have a form or a video online about this, why this actually works, the area of a triangle. And I'll just leave that up to you if you want to watch it. And there's actually a video on the law of sines working and why it works the way it is. So if you want to watch that, go ahead. I'm just going to shove the formulas in your face right now. Sorry. That means I'm just going to tell you that this is what actually works. Hey, what is area of a triangle? What do we know that in basic geometry? Ooh, good, nice. So area of a triangle is half base times height. Now I fear you writing that down because then my math tours kept trying to use this formula when we had the trig test on area of a triangle, but they needed a trig formula. I want you to trust me that through this one little drawing, if I make, by the way, this is side A, right? Opposite angle A right here. I can prove that when the base becomes side A, then the height of the triangle can actually be expressed as B times the sine of C. And I can prove that through this drawing, and this is what the person does online. They prove it. They prove that if I make this the base, side A, then the height can be expressed in terms of B sine C. It's actually true. Oh, and sorry, I forgot the half part. So there's your area formula in terms of trig. And again, I'll leave it up to you if you want to watch that video. But no matter what, you have to have this formula memorized. Watch how easy it is, though. What if I make side B the base? Well, then, quite simply, it ends up being B, and then side C, sine of A, is actually this part that represents the the height. And then one more for this, if I flip it around and make C the base, then it's 1/2 C. I want to make sure I have this right here. A sine of B. And really what that is side angle side in every single case. These formulas work when side angle side is given. That's what this represents perfectly. Look at side C, which would be here, that last formula, and then look at side A, and then notice angle B is in between them. That's a side angle side scenario right there that's given. Once that's given in that case, you can just stick the numbers in and find the area. All right. So again, the video proves why this is the case and why this happens. Look at BC sine A, side B, and side C. B and C, A is the in-between angle, the one in between them. So I have blank pictures here. Let's just throw some numbers in here. Let's say this side is 7. Let's say this side is 8. Let's say this angle is 56 degrees. Is that side angle side? Yes or no? Yes. Since it's side angle side, you can go ahead and use that simple area formula. A equals 1/2 7 times 8 times sine of 56. That will be the area of this triangle. And you can move on and be happy with it. Okay, and then just press your numbers and get your answer. Simple Simon stuff. Now I'm going to be a jerk. You ready? And this is what I get people to do this all the time. They just stick numbers in formulas, don't even think, and don't even use their brain. And it really aggravates me. 54. I'm sorry, 34, 56. And then let's say 7. Find the area of this triangle. I will get somebody to start sticking to 3 numbers in the formula. Is that side angle side? For the love of dog, it's not even close. Okay, so you don't have side angle side. So then how does he expect me to find the area? Find side angle side. What's the third angle? Is it 90 on the dot? Oh, that was an accident. Does that look like 90 degrees as far as the shape of that angle? I don't what? Care. It doesn't matter. Doesn't matter, but that ends up being 90 there. Okay, and then you know what? You can use 90-degree angles with law of sines. It's actually kind of cool. You can't use SOHCAHTOA and not right triangles, but you can use the law of sines and sine formulas for right triangles. So here's what we're going to do. We're going to make a choice. Now I have this angle measure opposite 7. So I'm going to set up the law of sines and find another side so that I create side angle side. Just one extra problem solve. It ain't a big deal. Who do you want to find? Doesn't really matter. So let's call this A. Let's go ahead and name this triangle ABC so we know how it fits the formula. So, okay, I'm going to find side A. And then this is sine C over C. So sine 56. I do need some help on this one, please. Go ahead and do the cross multiply and then calculate. So it's 7 sine 56 divided by. Okay, give me it out all the way because we're going to save that in our calculator. 5 point what? Keep going. Like what are 8, 0, 2, 3. Okay, so now let's highlight this. 5.80, dot, 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 dot. So now I have this side and this side. What angle must I use? A, B, or C? No, what angle must I use for the formula for the area? It's got to be B. Why? That is the angle that's what compared to those two sides? In between. That is SAS. Okay, that is SAS. That makes that work for the formula. It's got to be SAS that's plugged in. So once I decided to find side A as step 1, now I must use angle B in 7 because that's SAS, and that's the only way that these area formulas work, or this one. So 1/2, and then you could go ahead and just put 7 times, keep this all the way out, maybe saved on your calculator, and then sine 34. So remember what was given, which was the red. When the red's given, you don't have all the information needed to just stick it in the area formula. So you got to make that happen. All right. And then once I found and made a management decision on finding A, locate the angle that represents side angle side, which is angle B. And then this will be truthfully correct. Okay. All right. Good to go. And you see, I added some stuff there, the ambiguous case, which we'll start with tomorrow. So hopefully you don't mind the notes being like this. I think it works out pretty well.